Hello, my dear students. How are you today? I hope you're all doing fine and in good condition amidst our situation. Are you ready to learn new things? Come and join me. I am Rhona Ramos, your science teacher. Let's go! In your previous module, you have learned about sound and light as forms of energy that travel in waves. Let us test your knowledge in some of the previously used vocabulary words to check if you still remember some of the important concepts in your past lesson. Are you ready? Let's start. Direction. Complete the sentences by supplying the missing letters. A wave is a disturbance that transfers from one place to another. A wave is a disturbance that transfers energy from one place to another. Energy is correct. Number 2. Look at the letters of the incomplete word. Are waves that can travel through a vacuum. Electromagnetic waves are waves that can travel through a vacuum. The correct answer is electromagnetic waves. Very good. Number 3 is a form of electromagnetic radiation with wavelength shorter than visible light but longer than X-rays. Ultraviolet is a form of electromagnetic radiation with wavelength shorter than visible light but longer than X-rays. Ultraviolet is the correct answer. Good job! It really shows that you've already understand our past lesson. Now, let's play a short game. Let's try this. Look at the given pictures. What are common in them? Look at the clue. H plus, see the picture, what it tells, equals blank. Do you know the answer? Let's see if you're correct. H plus it equal to heat. Next time, we will study about heat, which is another form of energy that travels through moving particles or through radiation. We will determine the condition needed for the heat to transfer from one place to another and the direction by which it transfers. Our lesson for today is about heat transfer from the Module 5 in Quarter 3. Our objectives are: at the end of the lesson, you are able to define conduction, convection, and radiation. Explain when can conduction, convection, and radiation occur, and cite applications of conduction, convection, and radiation in real-life situations. Heat and temperature are two different quantities. Let us first differentiate them. The basic difference between heat and temperature is that heat is the form of energy that transfers from hot temperature to low temperature, while temperature is the degree of hotness and coldness of the body. Heat is a form of energy that can be transferred from one object to another or even created expenses of the loss of other form of energy. You have learned that heat is energy that moves from where there is more kinetic energy to where there is less. Heat transfer is the process of thermal energy exchange due to temperature difference between matters. This means that no heat transfer occurs between two bodies which are at the same temperature. To facilitate heat transfer between two matters, there needs to be a temperature difference between them. Look at the figure. There is high temperature, the warmer object, which is the hot region, the red one, and low temperature, the cooler object, the colder one, the blue. So, the transfer of heat is from high temperature area to the area of low temperature. Look at our example. The pot is placed on the stove where the stove produces fire. The stove transfers heat to the pot, which makes the pot become hot. Then, the pot transfers heat to the water, which makes it to start to boil. The process of transferring heat from one another is called heat transfer. In this sample, the stove transfers heat to the pot. This process is called conduction. Since the pot is already hot, the pot transfers heat to the water. This process now is called convection. When the heat is transferred to the surroundings, it now becomes the process of radiation. Based on the given samples, there are three modes of transfer of heat. Those are conduction, convection, and radiation. Conduction is how heat transfers through direct contact with objects that are touching. The key word of conduction is direct contact. Let us consider this figure. It happens when the particles of a solid matter, a metal spoon for example, are heated in one end. The heat will eventually pass through to its cooler end until it reaches the same temperature. This transfer of heat energy into a matter makes its atoms and molecules to vibrate even faster. When this happens, the heat will pass from particles with more energy to the ones they are touching that have less energy. The darker circle represents the atom of high temperature or the warmer atom, and the light-colored circle represents the cooler atoms of the spoon. Another example is cooking egg. As you can see, pan is in direct contact with the fire. It is an example of conduction. The hot pan transfers heat energy to the egg, causing it to become cooked. Another example of conduction is cooking rice. When the pot is hot, it transfers heat energy to rice. Consider picture number 1. It shows that the egg is in direct contact with the pan. In the second picture, rice is in direct contact with the pot. Both of them became hot because of the heat of the stove. This makes them as both examples of conduction due to direct contact with each other. There are two types of materials in terms of heat conductivity or the ability to absorb heat. These are Conductors and insulators. Conductors are the materials that transfers heat easily. One example of good thermal conductor is metal. This is why metal is used to make saucepans for cooking food, while insulators are the materials that slow the transfer of heat. One example of a good thermal insulator is wool. This is why wool is used to make winter coats, scarves, hats, and gloves. Insulators are materials that resist or prevent the flow of heat and electricity. They create a barrier in which it reduces and controls the flow of heat coming from a hot material source. The following are examples of insulators: glass, plastic, ceramic, rubber, wood, fabric, wool, cork, and paper. Conductors are materials that absorbs or transmits the heat rapidly. They have the ability or power to conduct or transmit heat, electricity, and even sounds easily. These are some examples of conductors: water, people and animals, metals such as platinum, copper, gold, aluminum, and silver. And also, another example of conductor is tree. The other types of metals which are good conductors are brass, aluminum, cast iron, copper, steel, and metal sludge. To determine whether you understand the difference between insulator and conductor, let us have this short activity. Look at the pictures below. Tell whether it is a conductor or insulator. Okay, let's start. First is jacket. Correct. It is an insulator. Next, frying pan. Very good. It is a conductor. We also have wooden window. Great. It is an insulator. We also have bonnet. Good job. It is an insulator. We have also metal. The answer is correct. It is a conductor. We have sweater. Very good. It is an insulator. Next, we have the aluminum pan. Correct. It is a conductor. Next, gloves. Very good. It is an insulator. We have bulb. Good job. It is a conductor. Next, cloth. Very good. It is an insulator. How about the doll shoes? Correct. It is an insulator. And the last one, we have the kettle. Very good. It is an example of conductor. Now, you've already understand the difference between conductor and insulator. Good job. Another mode of heat transfer is convection. It is the movement of heat in liquids and gases. It is the movement of fluid due to the rising of hotter materials, paired with sinking colder materials. The key word in convection is the movement of fluid. To transfer heat by convection, particles must move from a hot region to a cold region. When you heat a pot of water in a stove and you wait until it starts to bubble, these bubbles are actually the regions of hot water rising to the surface, thus transferring heat from hot water at the bottom of the cooler water at the top. This circular motion is an evidence that there is an upward buoyant force on the hotter fluid, making it rise, while the cooler, denser fluid sinks. This occurs because hotter materials have less density than colder ones. Hot coffee in the cup is an example of convection because of the heat of the coffee was transferred to the cup, making it also hot. Warm air rises because of heat of the fluid. Another example is the hot soup poured in the cup with metal spoon. Hot soup transfers heat to the cup, and also hot soup transfers heat to the metal spoon. The last mode of heat transfer is radiation. It is the transfer of heat in the surroundings that does not require the presence of material medium to occur. Therefore, heat travels through empty space. Let us consider this illustration. We can see that the black dull surface, example is an asphalt, is a good emitter of heat as its temperature rises rapidly. On the other hand, a polished surface like mirror is a poor absorber of heat as its temperature rises very slowly. Did you know the reason behind this? From your previous module, you can remember that black and dull surfaces absorb all the wavelengths of light in the visible spectrum. So, when it absorbs, it's also absorbing the accompanying heat of the wavelengths of light. Opposite to that, the light and polished surface doesn't absorb, and when it doesn't absorb, it doesn't get hot, and heat is being reflected. Radiation is different from conduction and convection, in the sense that it does not require the presence of a material medium to occur. Although we can see it, the heat we feel in our skin when we stand in the sun or put our hands over a hot stove is caused by infrared radiation, another type of electromagnetic radiation. There are also radiation that are difficult to feel compared to the sun because of the lower differences in the temperature between the source and the object. A good example is the radio frequency radiation from your cell phones. Another example is the electromagnetic waves from a microwave oven. Now, let's see if you understand the three modes of heat transfer. Time for a quick question and answer. What form of heat transfer is used when ironing clothes? It is conduction. Correct. Next question. What form of heat transfer is used to boil the soup? Very good. It is convection. Now for the last question. It is sunny day. You are sitting on the bench with your friend and eating ice cream. Suddenly, you notice that your ice cream is melting. How does it happen? Yes, it is radiation. Good job. That's great. It really shows that you have learned so much from our today's lesson. To sum it up, let us hear the song about heat transfer for you to easily remember them.
Mr. Paul, come on. Heat is transferred three ways. Oh, from one place to another in waves. Oh, always moving from hot to frozen. Oh, no, moves better through some materials. Oh, convection's how energy and fluids will go. Yeah, it's touching. Oh yeah. Electromagnetic waves go through space. Oh, the sun comes down with all of its rays. Hey, heating and object transfer by waves. Yeah. Examples of campfire, microwave. Yeah. Spectrum, radio, gamma rays. You feel the rays of the sun on your face. There's no air or in space. Radiation brings the heat to display. Convection, the way fluids transfer energy. Radiation, waves are traveling through space. Conduction, heat to solids. Oh, convection, they are current. Radiation, the spectrum. Conduction, break it down. Come on. I touched a heart rate while I was cooking. Ow, come on, I'll be screaming out when I feel the sting. Conduction's the transfer of heat if things join. It happens when substances directly touch. Conductors will make the heat travel faster. Good ones are copper, iron, steel, silver. Convection, wave fluids transfer energy, radiation. Waves are traveling through space. Conduction, heat through solids. Oh, convection, they are current, radiation. Convection, the wave fluids transfer energy, radiation. Waves are traveling through space. Conduction, heat through solids. Oh, convection, they are current, radiation, the spectrum.
Do you have any more question or clarification regarding our lesson? If none, it is the time for you to answer all the activities and assessment in your module. Thank you. Good luck. Have a nice day. God bless. See you next time.